everyone. So today we're going to be talking about free fall. Now you already pretty much know the equations that you're going to use for free fall. So this is just taking those constant acceleration equations and applying them to a new movement. Really not a new movement, but just a movement with a certain acceleration, okay? So first and foremost, just objects in free fall are under the influence of the Earth's gravitational pull. So you might have heard before that the acceleration of gravity on Earth is 9.8 meters per second squared. Now, sometimes you'll see g, as in the acceleration of gravity on Earth, is a negative 9.8 meters per second squared. So you might have seen that before. Of course, this negative just gives the direction of acceleration. We know that the force of gravity is always down. It's what keeps us on the Earth. So because the force of gravity is down, the acceleration of gravity is also pointed down, because we know from Newton's second law, which you guys might not know yet, you probably have heard it before, but force is equal to mass times acceleration. The force is what causes the acceleration, all right? So that negative is just because the acceleration is directed downward. Of course, you can call any direction negative in physics or positive in physics. So I could say that downward is positive, and then in those problems, then you would plug in a positive 9.8 meters per second squared. As long as you keep your signs consistent, you're totally fine. Okay, so like I said, we use the constant acceleration equations to solve these problems because the acceleration of gravity on Earth is semi-constant. For our purposes, it is constant. So where you're going to use that a equals 9.8 meters per second squared, and again, just be careful with your signs. You want to say either up is positive or down is positive, and then assign your signs following that notation. So some special considerations here. And speaking of, before I start talking about special considerations, I'm going to move my little picture. But you see this drawing right here, they have said that downward is positive. Can you see that? So as the velocity, as that object is thrown up into the air, we have a negative 19.6 meters per second. So they're saying upwards is negative, downwards is positive. Totally legal, all right? A little bit of, like maybe opposite of what some people do sometimes. A lot of people like to say up is positive, but this is totally legal as long as you keep your signs consistent. So if you're using this notation as down is positive, up is negative, then your acceleration of gravity will be positive. A lot of the time I will use this notation saying down is positive when something's being dropped off a cliff. If something's being dropped off a cliff, everything's going down. So you might as well just say that that's the positive direction. So it's just up to you, all right? So special considerations. If an object, speaking of dropping objects off the cliff, if an object is dropped off a cliff or dropped from someone's hand, the initial velocity is 0. So think of just dropping an object, right? If you open your hand, the initial velocity is 0 of that object, okay? If an object is thrown straight up into the air, it's gonna go up, pause at a velocity of 0, and then come back down. Okay, so the velocity at the very top is 0, and you can see that in this drawing as well. This is important because sometimes the questions ask us for maybe the maximum height of the object or something like that. So you can use this special consideration for that, saying your final velocity at the very top is 0. Another special consideration is that the path upwards and the path downwards are kind of like mirror images of one another. You can see that here in this drawing, the initial velocity is a negative 19.6, and then at that same point, as the object is coming down, the velocity is a positive 19.6 meters per second. You can see that here too. We have a negative 9.8 meters per second and a positive 9.8 meters per second. So they will be going the same magnitude of velocity at that point right there because they're under the same influence of gravity. But that velocity will have opposite signs, obviously, because they are going in opposite directions. Also, just remember that the acceleration is never 0 at any point in the object's trajectory. The acceleration is what's causing that object to accelerate toward the center of the Earth. So it causes the object to slow down in velocity as it goes up and then speed up in velocity as it comes down. Sometimes AP tests and things like that, multiple choice questions, they might try to trick you and say, when is the acceleration of the object 0? And your brain might want to say, oh, it's at the top because the velocity at the top is 0. Acceleration is never 0. It's always going to be negative 9.8 if you're talking about down being negative meters per second squared.